All right, section 8.1 starts off with the Pythagorean theorem, which you should have been exposed to first semester. Pythagorean theorem is a squared plus b squared equals c squared. So the key to these problems is just identifying the sides of the triangle and then plugging in from there. For a right triangle, the only side that matters is the hypotenuse, and that's going to be c. So I go from my right angle, draw an arrow across and label it C. And then from there, A and B really don't matter. I'm going to let 12 be A, 15 be B, but honestly, it doesn't matter. From there, we're just plugging into the formula. So you have A squared plus B squared equals C squared. I'm going to let you use calculators from here on out, so you go ahead and plug that in. So 12 squared plus 15 squared. It's going to give me 369. So that equals c squared. Remember, we don't want c squared. We want c. So to get c here, you go ahead and square root each side. And when we take the square root of 369, we're going to end up with a long decimal, 19.2 just going on. We want to round to the tenths place today. So the tenths place would be that first decimal spot. So for this first triangle right here, C is going to equal 19.2. All right. The second triangle they give us, they changed it up a little bit. Remember, the first thing you always want to do is label the side. So if I go right across from the right angle, we have C. Then you have to label A and B. Doesn't matter to me which one is which. This one's different because they go ahead and give me C. So we have to solve for either A or B. Again, plugging in, you got A squared plus B squared, so in this case 7 squared equals C squared. 10 squared is 100. So A squared plus 49 equals 100. From here, to solve for A, your first step would be to subtract 49 from each side. So we have A squared equals 51. Again, we do not want A squared. We want A. So you have to square root each side. When you square root each side, you're going to end up with a decimal again. We just want to go to the tenths, though. So it's going to be A equals 7.1. All right, so those are examples where they just give you like triangles and they want you to solve for missing sides. Remember, to use the Pythagorean, it has to be a right triangle. Okay, if it's not a right triangle, you cannot use the Pythagorean theorem. Example 2 deals with some application problems. So for A, they talk about safety regulations and setting up a ladder. They say the distance from the wall to the base of the ladder should be at least 1/4 length of the ladder. They want to know, did Drew set it up correctly? Well, the key to this problem is hopefully like a wall would make a 90-degree angle with the floor. We're going to make that assumption in here. For this right triangle then, if we're trying to find the length of the ladder, we're trying to solve for C. So we're going to have 2.5 squared plus 9 squared equals C squared. Okay, so again, calculator driven going through, you got 2.5 squared plus 9 squared. It's going to give me 87.25. You got to remember to take the square root. Hopefully you can tell that 87.25 is not the length of the ladder. Like, that does not make sense at all for the setup we have going on. So you need to take the square root of each side. Square root of 87.25 is going to give me 9.3. Giving us the length of the ladder, 9.3 feet. You go back to the problem. They say that the distance from the wall to the base of the ladder should be at least 1/4 the length of the ladder. Well, if my length of the ladder is 9.3, our next step would be to figure out what's 1/4 of that length. So 1/4 of 9.3 is going to be roughly 2.3. And they tell us the length from the base to the ladder to the base of the wall should be at least that. Okay, so at least means could be the same or greater. Since the 2.5 is greater than 2.3, we can say yes, Drew set it up correctly. All right, the last one we're going to look at here is B. So they talk about the length of the cross piece on the fence is 10 feet. They want to know, why would a rancher build his fence with the measurements shown? Honestly, I don't like this problem. The reason for it, though, is to see if we have a right triangle. I'm going to go ahead and redraw the picture. So you have 6 feet, 8 feet, 10 feet. And really, like, for this example, like I said, I just want to prove that the triangle is right. The way you're going to prove the triangle is right is by using Pythagorean theorem. So we go a squared plus b squared equals c squared. From here, we need to plug in, okay? Your c is always going to be the biggest side. So when we're testing, c has to be the big side. A and b doesn't matter. I'm going to let a be the small, b be the medium, and then we're plugging in. So plugging in the formula, we have 6 squared plus 8 squared equals 10 squared. Working it out, you got 36 plus 64 equals 100. Since this is a true statement, it works out. We can say that the triangle is right. So we have a right triangle. The triangle is right. Okay, so for any problem where they ask you to prove whether the triangle is right or not, you have to go ahead, identify the biggest side, make it C. The other two sides would be A and B. You plug in the Pythagorean theorem, and if you get a true statement from it, then we can say the triangle is right.